Alrighty, let's take a look at the week 5, our first lesson on the derivative shortcut rules. And you can see there is a long list of different rules here. There are kind of 3 primary rules. Number 3 is the power rule. And you can see rules 1 and 2 are just simplified versions for the cases where n equals 0, that's rule 1, and then n equals 1, that's rule 2. So they're all variations on that same thing. We have the exponential rule. That's the only type of exponential function we deal with in this class. We have our logarithm rule, and we only deal with the natural log in this class. We don't deal with other bases. And then we can see some additional rules at the bottom that I'll explain through the examples. So let's scroll down to, let's talk about the notation just a little bit. So I've used the y notation and the f of x notation for the function. That's normally what you're given. And so the derivative, sometimes I use y prime. That little apostrophe symbol you see in the function notation is in calculus is called prime. So this is f prime of x, which is the first derivative. We also do second derivatives in the future like that. I prefer the prime notation when I'm handwriting because it's a little bit less work there. Okay, so our first one. So let's identify the rules as we go through here. So we have rule 6 is happening. The -3 is the k, and the p squared is the g function in this case. And so you can see for our derivative, the k is going to stay there. These coefficients are always a part of the answer no matter what. And then the derivative of the g function, the p squared, that would go back to rule 3, where we have that exponent. And so the exponent goes in front to become a new coefficient, and then we subtract 1 from that exponent. And the second term, well, let's finish off, I guess, that one. So over here on the right, you can see my q prime of p notation is equal to, and this is very important to designate, this is the derivative. There's going to be some other examples where we are using a little bit of algebra with the function to set it up for the derivative. And so you have to be careful, that's not the derivative. So I like to keep these labeled separately so that I know the difference. All right, so the -3, that's the k. It's there in the answer. The p squared, the 2 goes in front. Subtract 1 from the exponent. And then we move on to the minus, and that's 2p. So that's the special rule number 2. Again, that's just a version. This is p to the first power. So if you apply that, you get 1 minus 1, which is 0, and anything to the 0 power is 1. But we abbreviate it with that rule number 2 there. And the derivative of constant times just the variable is just the constant right there. So minus 2p, the derivative, minus 2. Now, I would like for you to not do anything else. Now, I've played around a lot with WebAssign, and I have typed in a huge variation of things, 2 minus 1 in the exponent. It accepts completely unsimplified answers. And if it doesn't, let me know, and then I'll adjust what I'm saying here. But every time I go to WebAssign and I try different exponents, don't simplify things, completely simple, it accepts anything. So I'm just trying to get you to do less work and make a possible mistake by doing more. So apply the rules and stop. Do not do anything else. Exactly what I've got here. Now, I've decided in a separate video I'm going to address the simplification, because that really comes into play when you then go to Excel. Because you really don't want to type 2 minus 1 into Excel or -3 times 2. But when we're handwriting it, just apply these rules, stop. Do not do anything else. I'm trying to minimize the places where I see students make mistakes, and they make mistakes when they go a little bit beyond. All right, let's take a look at this next one. And this was what I was talking about. There is not a rule for a variable in the denominator. None of these rules apply. The function on the left here, nothing has a variable in a denominator. So in order to use rule 3, we have to understand some of the exponent laws. And I encourage you on your own to just go to Google and I can't type and talk at the same time, or whatever your favorite search engine is like that. There are a ton of these things. They're all straight out of algebra. They're not calculus things. So there are a lot of rules. We're using this rule with a denominator right here. So feel free to do that on your own and make a list there. So from the denominator, you can see that variable comes up to the top level with the 3, and the positive 2 changes the sign to negative 2. Now we can apply that rule number 3 in combination with rule number 6, like that. And I didn't mention that example A used rule 7. Oops, I'll talk about that on the next page. So the negative 3 coefficient, always there. And then the negative 2 exponent goes in front to become yet another coefficient. Subtract 1 from the exponent. Do not do anything else. I know the temptation is going to be to write 6, but I would much rather avoid the possibility you make some weird mistake. Just apply the rules and stop. All right, let's go to the next example down here. So you can see my first line, I have broken up the algebra, the exponent rules a couple of ways. So this one is the rule that deals with the root. That's this rule down on the bottom on my Google search here. You can see the root, the exponent that's attached directly to the x is the power, and it becomes the numerator of that fractional exponent, and the root number becomes the denominator. You can see over here the example, we have the square root of x to the 9th power. That fractional exponent becomes 9 over 2. Similarly, the one above it is a special case where the x doesn't have its own power, it's just a power of 1, and you can see the cube root x to the 1/3, like that. So be careful. I get a few students that get that fraction upside down, and that makes all you lose points for that. All right, so my first step was just to take that cube root of u squared and write it with the fractional exponent. And you can see the pi natural log of u, nothing changes. There's nothing there. And then finally at the end, pi natural log u, nothing changes. I've taken that 2/3 that's in the denominator with the u, moved it up to the same level as everything else, and then now changed the sign. So that becomes a negative 2/3. Now you can do the derivative. So be careful, keep the algebra. If you have to do algebra before you apply the derivative rules, keep that separate from the actual derivative. Alrighty, so pi is the coefficient. That's always there. The special rule for the natural log, rule 5, you can see basically it's just the reciprocal. Now, I'll give you kind of a foreshadowing or prelude to what we're doing in the future called the chain rule. All of these rules, 5 through 1, are simplified versions of what's called the chain rule. And it's a lot easier to see these in this kind of more specific and context form than to find them using that chain rule. But think about what this is. The inside of that natural log is x, and it becomes the denominator. It didn't change anything. What's the derivative of x? That's 1. That's in the numerator. So that's kind of what's happening with the chain rule. We'll get to that in lesson 3, but I just wanted to kind of connect the ideas of what this is. So if it is just plain x, natural log of x, the derivative reciprocal of x, 1 divided by, so scroll down there. So pi, derivative of the natural log, the reciprocal of what's on the inside, 1 over u. Then we've got a minus 2, that's the coefficient, so that's going to be there in the answer. The exponent negative 2/3 goes in front of the u, becoming a new coefficient. Subtract 1 from the exponent, stop. Don't do anything else. Just apply the rules correctly and you are done. And again, I have gone into WebAssign and typed some things like this and it said it was fine. So that's what I want you to do. Last example here, we've got the exponential. So this is both of these and example 1, example A, are Rule 7, where you've got separate terms separated by plus or minus, and you're just applying the derivative to each of those one at a time, independent of each other. So example A, the derivative of the minus 2p has nothing to do with the minus 3p squared. So likewise on this final one, each of these are 3 independent terms that you just apply the derivative to each one. So p squared, 2 in front, exponent 2 minus 1, you're done with the p squared. Minus 2 is the coefficient. Coefficient is always there. And then e to the just plain variable. Again, we'll get to more complicated e to the x squared. That'll be a chain rule that we'll look at in the future. But e to just the variable, nothing changes. That is just it. And then finally, the last one, the derivative of a constant, 0. And I actually had a student question this, and this sentence that I have on all of these worksheets, someone not writing that plus 0, I have 2 ways of interpreting it. 1, they did it correctly, but there's no evidence of that. 2, they just forgot the plus 3 and didn't know what to do, so they didn't write it down. I don't know which is correct. So that your instructor can more easily assess your mastery, the student that writes that plus 0, I can see that they know what they're doing. The student that does not write that plus 0, I don't know that they really understand. So again, I want you to apply these derivative rules and do nothing else. Each of these rules and stop. That's it. And I am done with this recording. So let's click stop and see what happens.